That means that we are ready for our final keynote speech. Jessica Deen here works for Microsoft and has graciously flown in to talk about some open source and cloud-related technologies. I'll let you get set up here.
Perfect. All the content and resources are also available online, so if for whatever reason you happen to be sitting on this side of the room and you want to play with everything I visualize and describe to you, you can go get all the resources at the end of the session. So this is Microsoft Linux Open Source Cloud and DevOps. My name is Jessica Deen. Again, I feel like I want to talk to this side of the room, but I know you can't see anything. So I am Jessica Deen. I'm here because I love technology and community. So I have the best job in the world because I get to do both. I am an engineer, but I also get to talk to people about engineering and code and give them tools and resources to go play with the same things that I do on their own time. I focus heavily on Linux, open source, DevOps, and containers. I love Disney and CrossFit Fitness, as we established for the latter. And then you can find me online at JLDeen at GitHub, Twitter, and Instagram. No relation to James Deen, so my last name actually has 2 E's in it. And that's actually also the best way to connect with me is through some sort of social media, because I travel and speak quite frequently, so I'm very rarely in email, much to everyone I work with dismay. Brief disclaimer real quick. The next 44 minutes at this point is not designed to make you an expert. It is designed to share a little bit about what Microsoft's doing in the Linux open source cloud space. There's a lot of things that I think people are still learning as far as Microsoft's role in this community. But the content I'm presenting is designed to get you thinking, to show you what's possible, to show you what's also around from the open source perspective, and then, of course, give you some sample code for you to go get started with on your own time. So I want to open up with a quote, and this is by Monty C.M. Metzger. Uber, the world's largest taxi company, owns no vehicles. Facebook, the world's most popular media owner, creates no content. Alibaba, the most valuable retailer, has no inventory. Airbnb, the world's largest accommodation provider, owns no real estate. Welcome to the world of digital economy. Welcome to the cloud era. Welcome to the fact that we're getting into 2020 and this more ubiquitous era, something that's more cloud focused. This is a different genre of technology than we've ever seen before. So to figure out how we can address this and adapt to this and handle this scale, this growth, this momentum, first we have to listen. And that was really key for us at Microsoft, specifically from the open source community as well. So here's what we hear from developers. I need to create applications at a competitive rate without worrying about IT. We all know the age-old saying, my application runs smoothly on my system, your server's broken. And finally, from the developer perspective, my productivity and application innovation becomes suspended when I have to wait on IT. In essence, IT is the bottleneck, right? We screw everything up. Don't worry, IT, I'm getting to you too. We get our moment. By the way, just a show of hands, how many people would feel comfortable identifying themselves as a developer? Awesome. And how many as an IT pro operations architect? Perfect. So we actually have a very healthy balance, right? So for the IT pros in the room, of course, our perspective is I need to manage servers and maintain compliance with little disruption. I'm unsure of how to integrate your unfamiliar application, primarily because I'm not firsthand a developer. So I need to work with you. I need to work with the developer. And I'm unable to focus on both server protection and application compliance and corporate policy compliance. So in essence, also from the IT pro, the developer becomes the bottleneck. So how can we remove the bottleneck in both situations? First, both developers or applications architects, operations architects, we all have the same stress points. So just because this says IT stress points, it's actually anybody who works in technology, right? If you touch software, if you write software, if you support the architecture that software runs on, these are all of our stress points. We all are concerned with security, we're all concerned with efficiency, and we all have to support this innovation and this growth and this momentum that we just talked about. And that's why all the products and tools and kind of focus areas I'm going to talk about today is so important. we are entering a new era of computing, right? The 1970s was the mainframe era. One computer for many users. The 1980s was maybe a little bit more personal. You maybe had one computer per household. The 2000s, of course, was more of a mobility era. Now you have several computers or devices per user, per household. And in 2010, that kind of became more of the cloud era, right? Now it's several computers, several devices, maybe Apple TVs, Chromecasts, all these things other than just computers. We also started seeing more things like containers and different tooling kind of coming out aside from just physical hardware virtualization. 2020 and beyond is slowly being called the ubiquity era, where it's going to be thousands of computers or microservices per user, per company, per household. At this point now, I live by myself, and I think I have 35 devices connected, and that includes my doorbell, my door lock, my light bulbs. But at this point, it's just getting out of control. And that's from a personal perspective. But you look at it, we have the same thing in corporate and enterprise. This is this new growth that we have to deal with, both as developers and operations. So that's why cloud is really important. Awesome. Good job, PowerPoint. If you have it up in the back, you can switch it to the slide I was just on, and I'll go from there. Otherwise, I'll try to restart it. Like I said, don't you love technology? So the slide that I was waiting for as it's opening was this is the cloud era, right? We're starting to see a completely different shift as we talked about. I'll load this. And we talked about the traditional model. We talked about how you have distinct infrastructure for each application. We had purpose-built hardware for that traditional model, right? Your operations and infrastructure teams were separated. I often use an analogy. It's like a sixth grade dance, right? You have people on one side of the room, people on the other. No one wants to come together. It's that awkward, I don't know what I'm doing. I don't know how I'm supposed to talk to you. And the processes and configurations were also customized. So everything was specific, was purpose-built. Your virtualization you were using was typically hardware virtualization. But the cloud model now has loosely coupled applications and microservices. You now have industry standard hardware, service-focused DevOps teams. And the processes and configurations are now standardized. We now have conferences to talk about these practices, DevOpsDays. So I know since we were at a DevOps conference, some of this just might be high level, but I want to give you Microsoft's perspective and role in DevOps. So first off, it's a three-stage conversation, right? We've talked about people. We know that we have standardized process, and then we're going to talk about some products, specifically open source. So this is the definition that my team stands behind. DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. The most important word in that definition is value. If you're not delivering value, what are you doing, and why are you doing it? That's why DevOps is so important. Using these practices and the tools and products I'll show you later on that are built on these practices will help you deliver value. Things like infrastructure as code or pipeline as code, continuous integration, continuous deployment, automated testing, performance monitoring, automated recovery, the ability to roll back and roll forward in the event of a failure. All of these are key practices, and you'll notice how some of the tools I'll talk about today are built on them. So now we've talked about kind of Microsoft's overall role, and this is our view on DevOps. We know the purpose for the cloud, but now what about open source? So why open source? Why do we care about it? Why does Microsoft care about it, or anyone in this room? More than 40% of CIOs have open source as a primary software strategy at this point. More than 60% of developers want to see cloud providers involved in open source software. And 90% of enterprises deploy some sort of open source software today. And this is a study that was done from the Microsoft CMR, Altoris, Trends from Open Source. And it's actually from 2017, so those numbers might already be a little higher. So this is Microsoft's growth from open source, right? And it's really taken a huge growth trajectory over the past 4 years. 2014, Satya Nadella came on board, and he really kind of changed the world and revolutionized, brought that whole Microsoft loves Linux world. We had the .NET Foundation created. 2015, we introduced VS Code. 2016, we had .NET Core and PowerShell Core and SQL on Linux. 2017, we had Azure Kubernetes service launched, and Microsoft joined the Cloud Native Cloud Foundation, Foundry Foundation. And then even in 2018, Visual Studio Code is ranked as the #1 developer tool. Service Fabric was open sourced. We announced our intent and now successful acquisition of GitHub. I mean, these are all really intense things that we've done in the open source industry. But aside from just what we've bought, how about what we've contributed? So this is our GitHub contributions. Back in 2014, we had right around 95,000 GitHub contributions. In 2018, we have 315,000. That's insane growth over the course of just 4 years. So now I'm going to show you one of our most popular tools, which is VS Code. I'm going to show you some of the open source options that it has, or extensions that it has built right into it. So we're going to go into that right now. Close out of this. Ideally, end show. That touch bar comes in handy for one thing: end show, find slide. Oh, and emojis, of course. So we'll go over to Visual Studio Code, and I kind of have it already loaded up. This is already a GitHub repo. If you zoom in here to the left, I have just a simple node application. It's Hello World, or Hello Chattanooga, to make it a little bit more personal. I also have, if we go over to the extension marketplace, and you search for Docker, which we'll zoom in here again to the left, you'll notice that I already have the Docker extension installed. It's the only extension I'm using for this demo. Now, this is open source. Visual Studio Code is cross-platform open source. The extensions are open source, every single thing I'm showing. Let's say that I want to get started with containers, and I want to, I don't know, get a Docker file and debug it. I can do that without ever leaving Visual Studio Code. To do that, I'm first going to open up my command palette and tell Visual Studio Code to, and we'll zoom in here just so people on the left, though I want you to be able to see as well, can see. And I'm going to go ahead and say add Docker files to the workspace. Now it's going to ask me what language do I have. I'll go ahead and choose Node. What port is my application serving on? It's serving on 3000. So I'll hit enter. Now when I zoom out, look at all these files it just gave me. I didn't have to write anything. It gave me a Docker file that you can go over and see. We'll drop this down just a little bit. It gave me also 2 Docker Compose files, including a Docker Compose debug file. Now the debug file is the one I really want to use, because it's neat that VS Code kind of did my job for me, and I don't have to write anything fancy for my Docker file. We'll go over, and you can see even in the Docker file, it's already exposing port 3000. But I want to debug my container live. So if you've ever tried to, aside from doing your debugging in Node, but you also have to go back over and debug your container, it's always not easy because you try to have to exec in and then try to figure out what's going on. You can do it live right from VS Code. So to do that, I'm going to first do Command-Shift-P. We'll go ahead and say Docker Compose up. And I'm going to choose my debug YAML file that VS Code created for me. Come on. I have a very special terminal. So sometimes VS Code integrated terminal doesn't like to work with my ZSH and my configuration, so I have to do it twice. You probably wouldn't, unless you want to use my dot files, which are also included at the end of the session. See, I get everyone to stay because they're like, what are you doing? I want that. You have to wait. So right now, you can see that it built my Docker Compose file. If I do a Docker ps-a, you can see that something named Laughing Murdoch is running, and if we scroll up, I have a few different, let's actually do just Docker ps. You can see right here, up 17 seconds ago, I'm not only port forwarding 3000, my Docker debug file also forwarded a second port of 9229, which is going to allow me to connect my debugger to it. So I'll go over to the debugger. We'll go ahead. You can see I have no configurations right now. I'll tell it to go ahead and add a configuration. I want it to add Docker. From there, I don't have to do anything else. It adds into my launch.json, Docker attached to Node, port 229. The container's already up and running. Let's go ahead and run my debugger. So that's now going to connect to the running container right now from everything. So I should, as soon as this pops up, I should be able to go into localhost 3000 and step in and step back. So let's make sure that that is working. Go over here to localhost 3000. hit enter, and there's my application. Now, if I go over to my actual, sorry, everything's always so big when I zoom in and zoom out, so we'll zoom out just a little bit here. And if I go to my node file, I should be able to set a breakpoint here and make sure the debug, so you can see the debug console right down here, server request received. Zoom out, refresh. I just hit my breakpoint, and you can see the third request received. So I don't have to do anything extra aside from use the Docker extension in VS Code to step in, step out, set breakpoints, create my files for me, everything. And the beauty of this, as we'll see later on with a few other tools, is I can use the Docker files and the debugging experience here to actually take that over into things like Kubernetes and run it in the cloud in AKS fully without, again, never leaving Visual Studio Code. So let me go ahead and kill the debugger. We'll go back over to the terminal window here, remove the breakpoint, and I'll go back over to PowerPoint. So we know that Microsoft has a huge involvement, as I pointed out, in Visual Studio Code and open source communities in general. And we know that we care about the cloud and Kubernetes and a whole bunch of other things. But if you've been around long enough, you also remember this. And I always laugh because when I first started going, actually I remember the very first time I was ever at a DevOpsDays, which was in Portland. It was only 2 years ago. Somebody comes over, very snarky, "What's Microsoft doing here?" I'm like, gosh, it's so harsh. I came from the open source world. Don't look at my Mac. But it's funny because I get asked about this all the time. Well, why is Microsoft doing this now? What about when they said this? That was 17 years ago. So for anyone in the room who has a kid who just graduated high school, yeah, they were born when this was going on. For anybody else who doesn't have a kid, J.K. Rowling was writing, not a movie, writing the 4th Harry Potter book. And the most popular cell phone at the time was the Nokia 8100 that had like the snake game that that's how old this is. This is today. This is reality. And it's not just something we say or something we throw money at, right? This is a quote, and I love this quote from Satya, right? "Judge us by the actions we have taken in the recent past." Going back 20 years ago does us no good. Our actions today and in the future. This is the future, this is today, this is the forward direction we're going in. In fact, a lot of people don't know that also when Satya came on board, he directed all Microsoft engineers to open source internally. So anyone at the company can see anyone else's code and use it as needed. And that vision is a day-to-day reality for Microsoft engineers. What's even more exciting is for a lot of the projects that we work on, a lot of the code is now also open sourced online for every open source community. So if you use VSTS, which is Microsoft's CI/CD platform, and now Azure DevOps is the rebranding name, you can actually go on and submit a pull request for any one of the extensions in that marketplace. Visual Studio Code extensions, you can go on and submit a pull request. Same thing for our docs pages. Who remembers how awful searching for Microsoft documentation used to be? Yeah, it's now open source. So you can go on, I contribute to it the same way that you would. Helm, Draft, Kubernetes, even though it's not a Microsoft-owned open source tool, it's one that we contribute to heavily. This is our day-to-day reality. So now we've covered open source, DevOps, cloud. But now, why did I show you something with containers? Well, remember the problem we talked about in the beginning, right? For both developers and operations. So containers, for the developer, enables this write once, run anywhere application. It enables and sets us up for microservice architecture. And for operations, it offers portability, right? So now we can have standardized development, QA, production environments. It pretty much removes the bottleneck, including a few tools I'm going to show you in a second. So first off, let's talk about container orchestration, now that we know why we care about containers. And for anyone who doesn't know what a container is, it's not a real thing, actually. It's process isolation for an application delivery mechanism built on Linux kernel features, right? So it's just essentially encapsulating your runtime environment, allowing it to be immutable. Now, a container orchestrator, like Kubernetes, is open source, and it automates deployment, scaling, and management of those immutable applications. So things specifically Kubernetes offers is things like bin packing, self-healing, horizontal scaling, service discovery, load balancing. I can even manage my secrets for private registries. And then also people, I'm assuming know, but it was designed by Google. It's based on the system that was called Borg that they use to run billions of containers per week. There's over 2,300 contributors to the project, including Microsoft. IBM is another one, Red Hat is another one. And as of March of this year, it was the first project to graduate from the Cloud Native Cloud Foundry Foundation. If you want to learn more about the graduation requirements, you can go on their website. I think it was slowly followed by Prometheus, which is a logging and monitoring tool you can use with Kubernetes. So if you've played with Kubernetes at all, you know that it's probably also really complicated, right? I just debugged a container. You're like, that's cool, but getting in Kubernetes, I got to write charts and YAML, and I'm a developer. I don't do anything with architecture. We'll help you. So first off, we have quite a few different tools and products that will simplify your Kubernetes journey, your DevOps journey, your cloud, Linux, open source journey, because they're all open source. So Open Service Broker for Azure is a big one. It actually will allow you, using OSBA, you can connect partner services, so whether that's OpenShift, Cloud Foundry, Docker EE, or DCOS, you can connect that over to services that are running in Azure, things like Redis Cache or Cosmos DB or your SQL database and more. What's more so is you can also use, on the other hand, if you are using Azure Kubernetes Service, which is our offering of Kubernetes, it is not a Microsoft fork, it is 100% upstream, open APIs, you can use that also with OSBA. So what that means is if in production, I want to also connect over to my SQL database or create and provision a database for me, I can do that as part of my Kubernetes deployment and not have it live within my Kubernetes cluster. I can also connect to Azure Container Instances, which is you have no control over the cluster, but you can run an image backed by Kubernetes. Virtual machines, if I wanted to go back to 2000. Service Fabric, batch jobs, it's really quite powerful. And even down to Azure Container Registry, which as of, I think it was 2 months ago, almost 2 months ago, we also announced support for Helm charts in addition to Docker images. So now you can have private Helm chart repositories. And we'll talk about Helm in a second for anyone who doesn't know what that is. A little bit more about OSBA. It's a standardized way to, again, connect with Azure services specifically, and you don't have to use AKS. You can use something previously. It's simple and flexible, and it's compatible across numerous platforms, as you can see right here. So you essentially have OSBA in the middle, and it'll connect whatever you're using over to your database storage or whatever else you need over in Azure. Now, I mentioned Helm as well, that you can use with Kubernetes in addition to all these tools. And that's just one of 4 really big release automation tools we play a part in. So Helm was originally created by a company called Deis back in 2015, and we acquired Deis a little over a year and a half ago. It is the package manager for Kubernetes. So if you've ever had to try to write or deploy something to Kubernetes, right, you have a YAML file. Usually it'll have a deployment, it'll have a service, and that's a little different than Docker because you're creating your actual deployment of a pod where you can have multiple containers in that pod, and then the service exposes that. So it can get very complex very fast. Helm uses a template engine to parameterize everything. So you now just have one YAML file you make changes to, and then Helm goes off and parses that through, and we'll take a look at it. But even with Helm charts, it's called a chart for your release, for your package, as easy as it makes it, of course, the creation of it is where things get hard. So that's where Draft comes in. Draft will streamline your development of those charts. Then we also have Brigade, which is event-driven scripting for Kubernetes, kind of like a Kubernetes-specific pipeline. And then even Kashti, which is a visualization dashboard for Brigade. Now, we only have enough time really to go through 2 of these, so I'll show you that in just a few minutes. So just to give you a little bit more definition about Helm, it is the best way to find, share, and use software specifically built for Kubernetes. You can manage even the most complex workloads, including, like I said, if you are using Open Service Broker for Azure, you can manage that as part of your entire release, which means rather than having to do kubectl, delete deployment, kubectl delete service, kubectl delete secret, kubectl delete ingress, and you're managing this complex deployment, I just do Helm delete, name a deployment. Or if I want to permanently delete it, Helm delete purge, name a deployment. And it deletes everything that it deployed. What's also really cool is aside from being able to create your own charts and your own packages for your own applications, there's actually again, open source Helm charts that's available online for you to use so you can get started with deploying out applications you would normally have to deploy. For example, how many people in the room absolutely love setting up Jenkins from scratch? God, I never get any hands. So there's actually a Helm chart for Jenkins. I'm going to show you a Jenkins build server as part of my demo. That build server was deployed as part of a Helm chart. And I was able to deploy it in 5 minutes because just as you would any other normal package, I say I want to deploy Jenkins, but I have my requirements. So I use that one file I told you about. It's called a values file, and that's the knobs and dials. And that will deploy out Jenkins with everything I specify in the knobs and dials file. That's it. And I'll show you what that looks like in the resources that you'll get at the end. You can also do easy updates. So fun fact, I accidentally, last night apparently, deleted my deployment on my Kubernetes cluster that I was going to show you in today's demo. So I'm practicing it this morning. I'm like, why is the website not working? I deleted it. Guess what? I was able to recover in 3 minutes and 28 seconds because it was a Helm chart and it was already tied to CI/CD, and all I had to do was say, hey, redeploy. Everything, including down to the FQDN, the service, the DNS, the ingress, the SSL certificate, everything was redeployed in 3 minutes. And then simple sharing, I can share that out from a public or private repo, and I can quickly roll back. In the event of a failure, I can do Helm rollback to whatever the release version is, and it'll recycle everything through. Here's a better visualization of a chart. You take your services, your load balancer, your CI, your database, everything that you have defined in your declarative YAML, and you pop that into essentially just a little package. It's packaged up into a tarball. And then Draft simplifies, again, the Helm chart creation even further. So if you're not using something that's pre-made and you want to take something and do a draft file out of it, or do a Helm chart out of it, you can use Draft. Using 2 simple commands, I can get started locally on my system, not even touching the cloud, with creating my Helm charts for me and then testing it and debugging that locally. It does that through called draft packs, where it'll actually detect the language I've written in. So now, because PowerPoint is boring, let's actually look at a demo. All right. So remember the application I used earlier, right? We have Docker and everything working. I'm going to go ahead and do Docker compose down because I actually don't need Docker anymore. Now, what I am running, if you look up here, is I do have Docker running on my system. And right up here, you'll see it's Docker for desktop, nothing fancy. For anyone who can't see, it says Docker is running, Kubernetes is running. I'll show you a bigger version of that right here. Go to preferences. On the latest version of Docker for desktop, both Windows and Mac, you now have a Kubernetes tab where you can enable Kubernetes for your local desktop. Okay, so we'll close out of this. You can also see down here in my customized terminal, I'm using Docker for desktop. This is not the cloud whatsoever. I don't have any Helm charts. I have a Docker file already. I now want to do that. I now want to get this ready for Kubernetes, right? I know that my operations architects are now going to need to use this in their CI/CD system. So let's check in source code with the same files that they're going to need. They can edit the application architecture, and I can edit my code. So if I do draft create, remember 2 commands. Draft create is going to detect my language, which it just did. It detected JavaScript, and it gave me a ton more files, including a charts directory. And this is the charts directory where I told you it creates templates, right? So here's this values file that's everything's just in one file down to my service, my resource information, ingress information. I do need to update the internal port to be port 3000. And you can see over here on templates, if you go to the deployment file, my deployment file now looks a little different than a standard one. I'll show you a standard one in a second. Under replicas, for how many specs, how many replicas do I want in my container, rather than giving it a number, it gives it a reference to go look at the values replica count. So you go back over to the values file, and you can see the replica count is specified right here on line 4. So I can change that at any time. I don't have to go back and edit multiple YAML files. Now to show you what an original deployment file looks like, you have something like this. Look at how many times the same word or the same thing is repeated throughout your files. And then it's done the same time not only in your deployment file, but then in your service file, and then your ingress file. So if you update something in one file and you forget in the other, there's going to be breaking changes. Helm allows you to keep that consistent, and Draft just created the files for me. So now I can do draft up, and that's going to build my Docker image, and it's actually going to release it into that local Kubernetes cluster. And now I can test everything out from a Kubernetes perspective. So if I zoom in here, just to show you. kubectl get services is going to show me there's my service that was just spun up 11 seconds ago. kubectl get pods. There's my pod that was just spun up 19 seconds ago. This is all truly live. And now, I could do, of course, kubectl port forward and connect over to the deployment, but that's too complicated, because if I'm a developer and I'm new to this, I just want to debug. So the one final command I need to use is draft connect, which is going to connect through a proxy over to that running pod in my Kubernetes cluster. I simply copy the proxy port forward. We'll zoom out. We'll go over here. We'll paste this in. And there's my same application. And you can see, again, the localhost has changed. And just to prove that it really is that application, we'll cancel this. We'll go over to the node YAML file, and we'll make one change. We'll do live, save that. We'll do draft up one more time, because it does have to rebuild the Docker image with the new node change that I made. It'll re-release the new change. I'll do draft connect one more time. Grab the new localhost connection, go back over to Google Chrome, paste that new one in, and there's my new live change. So now I've taken, again, all through Visual Studio Code, taken the ability to not have any Docker files or Kubernetes files, and using things like the Docker extension or the draft extension, be able to iterate really fast. But how does this help me from, again, a DevOps perspective, cloud perspective, into actual checking in code? Well, I have on GitHub, I have a repo that's, again, in the links at the end, but I have a branch here called Jenkins. So this is where I told you that we have a hub. Let me just show you that real quick. hub.kubapps.com. This is the same thing as our open source Kubernetes applications for Helm, which just happens to be over here. But this is kind of boring and scary. This is pretty and easier to understand. So you can see we have a wide variety of different charts, right? You have WordPress even. That's a chart that I could just install if I want to do a WordPress installation. Going back over, we'll type in Jenkins. So this is my Jenkins build server that I'm going to show you. I use this same chart, and I have it right over here. So we'll log in a second. But I have a whole Jenkins pipeline set up. Now, this pipeline has the charts directory added. This is the same exact charts directory that I generated using Draft. The only changes that I made was changes that I, as an operations architect, would make. I set up my ingress controller, my fully qualified domain name, my pull secrets for a private image. I did what I would do that a developer wouldn't have to. But I can work in the same repo on the same branch. And so you can see the differences, specifically in values. If you look at the values here and zoom in, you can see I added an ingress, I enabled it, I added a host name, I gave it an ingress class, all these things that developers don't need to know. But because they set up the scaffolding, I was able to go in and add additional things that I would need. So I was able to do my own development for architectural development. So zooming out, we'll go in here to Jenkins, and I'm going to enter in my password. So you'll see actually here that I have 3 different runs of this. So this top one, if you zoom in here real quick, you can see it was completed 2 hours ago. That was the replay of my deployment because I accidentally deleted what was on my cluster. I replayed it, and it took 3 minutes and 28 seconds. So if I zoom out and you click in, again, I have even down to the pipeline is available online. But you look at the shell script and zoom in. This is where it used Helm to install my deployment, even down with the ingress host name, image tag, pull secrets, because it is a private repo. But this is the part I really want to show you. So when I scroll down, you're going to see the resources it deployed. Remember how I told you have all these different individual charts. To manage them individually is quite complex. But using a Helm chart, it deployed out the deployment, the ingress controller, 3 different pods. So you see 2 of them are running, 1's creating, and then even down to the service as well. Now if I zoom out and we go back to the previous deployment that I had deleted before, you can still see the shell script insight, but there's one thing that's going to be different. This was a previous one that I did as a rolling update. So I like to have multiple replicas in my Kubernetes clusters, so it'll kill one, slowly spin up another, kill another, spin up another, kill the final one, spin up another. So at no point in time do I have downtime. And you can see that Helm was doing just that right here. It's terminating, it has 2 running, the final one's terminating as a new one's being created. So there's no downtime, everything's cyclical. And again, there's an actual whole team at Microsoft dedicated to Helm and Draft and Kubernetes and all of these amazing open source tools for DevOps, containers, all of this. So since everyone I know wants to see that the application actually got deployed online, we're going to go through and refresh this real quick and zoom in. And you can see not only is the application, you could even go to it from your mobile device, node.k8s.az.jessicadeen.com, but that fully qualified domain name for the ingress was created. And if I click the little lock, you'll notice that it even has a valid Let's Encrypt certificate that was also handled through a Helm chart for a certificate manager on Kubernetes, all again open source tools. So we'll close out of this real quick, zoom out, go back over to PowerPoint. Oops, that was terminal. And we'll recap a little bit. Because I know there's a lot of information here, but the important part is to show you kind of all the different tools and products that exist from the open source world that can simplify your enterprise environment. So in the demo, I have code living out on GitHub. Jenkins has a Kubernetes pipeline all set up, and it's just using a Jenkins file. So I gave this session at Jenkins World in Paris in October, and my Kubernetes cluster crashed, Jenkins crashed, everything crashed. So I had to rebuild it at 2 o'clock in the morning, and I was on stage at 10. There's nothing more stressful than being a speaker and watching things break. But because it was a Jenkins file and everything was already in GitHub, I just redeployed using the Helm chart. That took 5 minutes, clicked the Jenkins file, said, OK, build my demo. And it was done in 30 minutes. But I did freak out for like 15 and slowly cry, so technically 45. So Jenkins pipeline, it handled the build of Docker, it handled the package of the Helm chart, and it deployed it to Kubernetes on Azure. It used Azure Container Registry as my Docker image repository. But I want you to notice everything that I had Jenkins do was everything that I did manually, locally as well. So I can take everything that I go from a local environment and get that into a running cloud, real-world application. Because at the end of the day, it doesn't matter if it's dev, staging, QA, or prod. I'm using products that are synonymous with every single stage. So there's one more thing that I want to kind of recap. If you know GitHub and have followed them for the past few years, they do an Octoverse report every year. And I always love following it. I love seeing where kind of Microsoft falls in it. So this year, this came out, I think, back in October. The #1 top open source project was VS Code. I used to be huge on Sublime and Atom, and I still do love living in my terminal, because trust me when I say it's highly decked out. But I love that I can bring that terminal into VS Code. I can still have my IntelliSense and everything I would use for VS Code, because aside from Docker extensions, you can also have Kubernetes and Helm extensions, which will give you IntelliSense for if you do start editing Helm charts. But VS Code was not only the top open source project, we had 19,000 contributions, almost double Facebook and TensorFlow for React. Sorry, not Facebook, but React Native and TensorFlow. On top of that, the fastest growing open source project, remember I said earlier our docs was open source, that's actually become the fastest growing open source project across all of GitHub. There's a 4.7 times change, even beating out PyTorch and Ethereum and Wix and Spider and TensorFlow again. So that actually surprised me, and I was even more surprised because number 9 on the list, Home Assistant, I use that at home and have been for the past 4 or 5 years. And we open sourced docs pretty recently, I want to say within the past year or two. I never would have thought that just in this year alone, we became the fastest growing project over something that I've used for the past 5 years. And then on top of that, open source contributions made by employees. So mind you, I am a full-time Microsoft employee, speaking from my Apple computers. My backup system is also Apple. My job is to talk to people about DevOps and open source. That's where I'm passionate about. I love that this is the new Microsoft, right? We have open source contributions made by Microsoft employees. That's part of our job. I love getting to go contribute to open source projects to the point to where we lead the trend. We have 7,700 contributions just by employees alone, and we beat out Google, Red Hat, and even UC Berkeley. And then finally, we have about 5 to 6 minutes left, and I know we were running a little bit over on time from previous speakers, so I'll give you some of your time back. But thank you again for having me. It's been an absolute pleasure to be at Chattanooga. All of the resources for every single thing I demoed, including my dot files, is available at aka.ms/DevOps/Chattanooga. I am hugely passionate on anything that I do on stage, especially when it's a public conference, is also open source and online. So you can also check out any of my GitHub repos or anything at Deen. That's also where you can find me on Twitter and Instagram if you want. Instagram is honestly pictures of code, my puppy, and CrossFit, so I apologize in advance. And again, remember, no relation to James Deen, 2 E's in my name. Thank you very much.